All right, hello everybody. I am back for our second part of this video series. We're covering Learning Target 4.1 on graphing. Previously, we made this graph by going over the basic level, which is graph creation. We're done with that, and then this video is going to be at the meets level. Oops, I can smell meets, which is on slope calculation with units. All right, so I'm going to erase this, but you can write this at the top of your paper. All right, so previously I stated that we need to identify 2 points that our line went through, which I very carefully made sure happened. So I'm just going to choose 2 points. It's better if they're spaced out a little bit more, but just decided to pick those 2 points. Now, we can calculate this by doing rise over run, or by doing y2 minus y1 divided by x2 minus x1. Either of these will work, but there's an issue that we run into with rise over run that we will not run into if we do the equation that we see here. So we'll start with rise over run, and I'll explain what I mean. So the first thing that we have to do is determine what our ordered pairs are for these points. So what I do is I can either estimate that. I can go, okay, that looks like maybe 19.5, and then if I go back over here, let's see where this gets tricky. This is 425, that's 450, so maybe 430. Okay, guess, but we have our data table over here. So I'm looking for something that's between 19 and 20. Maybe that's 19.4. And that looks like it's it. So then this number over here would be 412. So 19.4, comma, 412. That'd be my first ordered pair. And then my second one, I'm looking for something that's between 25 and 25.5. Oh, that's this one I've circled here. And then my other one would be 614. So I got my 25, 1, and 614. Okay, so that's my ordered pair that I'm going to use for these calculations. Now, remember, rise tells me what's happening on the y-axis, and the run is telling me what's happening on the x-axis. So my rise would be going from my ordered pair here, got my x, got my y. So my rise is going from 412 to 416. And the way that we'd figure out how much that goes up by is by, well, subtracting these. I could go up and I could count boxes, but that's a little bit tricky since this isn't on an even interval of a box. If I would count up in my boxes, you have to make sure that you count up in the interval that you set on your axis. So on this one, I went up by 25s. So if I wanted to count up, I'd go 25, 50, 75, 100, 125, 150, 175 is what that would be. But that's not very exact, right? Because that's not on an actual box. Also, something to keep in mind, if I wanted to do box counting for my run, I didn't go up by ones, I went up by half a degree. So I'd have to go 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.55, 5.5, and then that's somewhere in between, so I have to guess. Now this is not ideal because, again, these are not even intervals of boxes. So on the flip side, what I have to do is, what would be more accurate would be to use my y2 minus y1 over x2 minus x1. Now, to do this, as you've been taught in your math classes, you need to identify which ordered pair is what. So I'm going to call my first one 1 and my second one 2. Now, you can call the first one 2 and the second one 1. It does not matter as long as you're consistent. So I'm going to label my points. So this first one, since I decided this was going to be 1, let's rewrite this. I'm going to call this one x1, and then this one's going to be y1. And then over here, I'm going to call this x2, And then over here, this one would be y2. All right, so let's see if I can scroll down here. I'm going to erase this garbage. I'm going to rewrite this y2 minus y1 divided by x2 minus x1. So my y2 is 614 minus my y1, which is 412. Divide that by my x2, which is 25.1, minus my x1, which is 19.4. Okay, I'll type that in my calculator. All right, and this is what I end up getting for my y. I get 202, or my rise. And then for my run, or my x, I end up getting 5.7. Okay, so now, here's where an interesting thing happens, and I would be surprised if you talk about this in your math class. But what I'm interested in in physics is, what do these numbers mean? And we get meaning from the units, right? And these are all naked numbers up here, so that's really embarrassing. And these are super naked as well. So in order to make them not naked anymore, we have to just figure out what units there are that are going to go on here. I've got my y, so what I have to do is go back up to my graph and look at what units I had on the y-axis. So my units on the y-axis were dollars. So I can come down here and I can say dollars. Okay, or I could write the dollar sign. Same thing for the x. It's 5.7, but it's 5.7 what? So I look down here, and my units for temperature that I measured were degrees Celsius. Okay, now they're not naked, and now they actually have meaning. So what this tells me is that for every 5.7 degrees, there was an increase in price of $202, which is pretty interesting, don't you think? This doesn't really make me feel great right now, because I can't make a for every one statement out of this. So we're gonna type in our calculator and get a decimal out of it, likely. 202 divided by 5.7. That equals a whole bunch of stuff, but I've got 2 digits here, I've got 3 up there. So let's just go ahead and say 2 digits. So I've got 35 and then some decimals, but since there's 2 digits there, I'm only going to keep 2 digits here. 2 digits here, and then my units would be dollars per degree Celsius. Or, the way I like it is $35 for every 1 degree Celsius, because if I put a 1 down here, that doesn't change my dollar amount on top. So this would be my answer. Or, this would also be appropriate. The next video is going to talk about how to interpret our slope, which shouldn't be that hard of a skill to accomplish. Stay tuned.